Present day, everyone. I'm Sarah Dang, a master student in Bugyeong National University. Today, in WISA 2021 conference, I would like to present a paper entitled Blockchain-Enabled 5G Edge Network and Beyond, an intelligent co-silo federated learning approach. This paper is collaborative work with my colleagues, Sandy Ramadika, Muhammad Firdaus, and Professor Kyung-Han Lee. This paper is already published on the Security and Communication Network in the early of this year. For the further information, please visit the website. Recently, federated learning and blockchain are heavily implemented, but these technologies are open publicly, where every condition can be observed candidly. While Edge Network enabling the design of various flexible and customizable apps by integrating with blockchain and federated learning, it can provide better services, but however, Edge devices are running on untrusted networks. So to handle these issues, we provide a dynamic authentication protocol with blockchain as a rewarding mechanism in co-silo federated learning approaches. In structure of blockchain, the nodes are separated into the same peer-to-peer network to solve the mining puzzle. Blockchain structure is generally consists of blockchain header and body. In header, there are hash of previous block and Berkeley root. This makes blockchain is tamper-proof, while in the body consists of transaction data. This is backbone of our research, particularly federated learning is a decentralized learning provided by Google AI team to protect clients' privacy, where the data never leaves the devices. As shown in the left side figure, this federated learning applied on the Mozilla browser to determine URL ranking prediction, and it also applied in healthcare area. We are running the cross-silo federated learning in the Edge network. Edge network consists of three planes, namely cloud plane, edge plane, and user plane. We also provide dynamic authentication scheme because in edge plane, originally we need to frequently register in order to use that services. To address these issues, we provide the dynamic authentication scheme. As shown in the left graph, it consists of three planes. In user plane, it is literally user equipment or devices. In Edge network, it consists of micro base station and load side unit. In cloud plane, basically is cloud computing. We constructed dynamic authentication using bilinear pairing techniques where entity can use our shared key. It can be designed by taking public parameter and master keys for every entity. For instance, user equipment wants to make a transaction. The user equipment won't take public key of micro base station and the public key of cloud and sign it by using user equipment 1's private key. We use the network digit dataset. It consists of 10,000 synthetic grayscale images. We use the 2D convolutional network, and the rest of setup can be seen on the slide. The following is the performance of federated learning. We distinguish our experiment based on the number of data used in training. In Figure A, visualize the least number of training data. Contrarily, the Figure B holds the maximum number of images. In terms of accuracy and rules, Figure B shows better results compared with Figure A. Eventually, we perform a dynamic authentication. In here, we take three keys and compare with two keys to execute federated learning transaction. Roughly, the blue one needs longer time compared with orange one. Next, gas usage in conducting transactions. We compare user estimate and cloud. The amount of gas quite different with each other because the arbitrary values within the smart contracts are comparable. The detailed information can be seen in Table 1. I'll briefly summarize our research. We have performed supplementary protocol to be applied within co-silo federated learning and Ethereum smart contract in untrusted edge network. Our dynamic authentication protocol successfully deployed. Finally, the overall results possibly recommend that our scheme satisfies the design goal. I appreciate your time. If you have any question, please drop your question through this email. Thank you.